Well, hello again everybody, and welcome to another episode of This and That. I've spent a couple of hours this evening just playing with this Midland 3001 radio. We've got a bit more life into it. One of the things I've done is I've cleaned up the front, so I took the front panel off, took all the knobs off and used my favourite tool, which is the wife's toothbrush, and I managed to scrub in all the nooks and crannies and give it a good clean. So the front's looking quite smart now, I think. It's still got a dent in this corner. I did give it a bit of a bash with a hammer and I think I've straightened it up a little bit, but yeah, apart from that it's okay. Seems to be going through all the channel selecting okay, that's working fine. And one thing that was not working on it is the squelch control didn't work. But if I actually just turn the squelch control now, it still doesn't work. No, wrong way. So we now have a working squelch, and what that came down to was one of the, it was a squelch trimmer pot, and yeah, it was a fairly easy fault to find, to be honest. Let me show you. So the squelch on this radio is handled by this IC here, which is an MC3357, and I think it's described as a demodulation IC for mobile communications equipment. So it takes in the first IF, which is, I'm guessing that's 10.7 megahertz, and then I think it downshifts it because we've got the second IF here of 455, and then it does some, well, it does a demodulation as well, and then some bits of filtering. But right at the end of this functional block, we've also got the squelch. I actually thought it's quite interesting the way that the squelch works. What it actually does is, when the squelch activates, you see, hopefully you can see they've drawn a switch symbol there. What it actually does is it pulls the audio output from the detector, from the detector IC. It actually pulls it down to ground. So that's how the squelch operates. So you can see that this line here normally feeds, can you see it? Yeah, hopefully you can. It normally feeds the input to the audio amplifier, which is, let me move along, is down here. But what happens is when the squelch activates, it actually just grounds this wire. It pulls one side of the switch is connected to the ground rail there. So what controls the squelch trigger? Well, it's quite clever the way the circuit works. Again, I keep mentioning this magical thing of FM quietening, but that's what actually how the squelch operates on these. It actually looks for a reduction in signal. It looks for a reduction in noise, which comes about of this FM quietening. And what FM quietening is, I'm going to bore you and tell you again. Whenever you put an FM signal into an FM radio, what you'll find is when you feed the signal into it, the background noise drops remarkably. And there's lots of reasons for that, but one of the main reasons is because actually, if you look at these IF stages, they're actually driven very hard. We've got an awful lot of amplification going on throughout the radio. So when an FM radio has no signal, it tends to be very loud at the speaker, which is not the same as an AM radio, which kind of almost doesn't change that much. But FM, you get a very definite quieting effect. This squelch unit, what it actually does, it looks as though it does something like it rectifies what I'm guessing is some of the noise and then smooths it or something like that, and then feeds it back into the squelch trigger, and that's how it knows whether or not you've got a signal. It's listening for this FM quietening. But if we go a bit further up here, we've got the squelch control pot, which is this 10k pot. Now that is the one that's on the that's actually the one that's on the front of the radio, so that's the squelch control, and underneath it we've got a 2k2 squelch preset. And I've just noticed that I've actually made a bit of a cock of that because I must have misread it because I put a 10k in there. Oh well, it seems to work, and yeah, probably I'll bother moving it because it's working. What I actually found was when I thought, well, probably this trimmer needs adjusting. It was always worth a try, so I just touched it with the end of my trimming tool, and the actual pot just fell into pieces. So here's the pot that I've incorrectly replaced with a 10k, but it seems to work. All it does is it just pulls down to ground. So probably what I've done by having such a big resistance range is I've probably made it harder to adjust because I'm compressing all the usable range to one end of the trimming pot. Well, it's working, so maybe I'll change it, maybe I won't. The pot I've used is quite a high quality one. I think it's one of these that, just feeling it, it's on like a ceramic substrate, so that would have been expensive, and yeah, I'm guessing I probably stole it from work at some point in the past. So it's got a very nice 10k trimmer in there now, and it works. Let's just give it another burst. I guess what we'll have to do is we'll have to try injecting some signals into it and then setting that up precisely. It's a big improvement, the fact that the squelch works and it didn't before. So here's the old trimmer part, and as I said, as soon as I touched it, the trimming part, this is the top piece there where you put the thing in and turn, that just fell off, leaving this very sorry mess. And as I tried to unsolder it, basically the legs just fell off the bottom. So this radio just shows some signs of having water ingress. So obviously it's had some water sat in here and it's done some damage. And looking at some of the other presets, they also look a little bit scruffy as well. So I'm guessing that I might change them out. Now, I think I said in the earlier video I wasn't planning on doing a recap, so I wouldn't mind you leaving some comments. I mean, what will this be now? It's probably 30 or 40 years old, so I'm guessing it probably is due for a recap. But I'm just wondering, do you routinely recap these CBs? I'm guessing I probably should. And at first, when I first got the CB, I thought, well, I don't care, as long as it works a bit, it's good enough. It was just a beta to learn on, and I didn't really want to spend the money on caps. But you probably find the same thing. When you work on a piece of equipment, you get a little bit attached to it, or certainly I do, because I'm maybe a bit of a big girl's blouse. So having spent a few hours invested a little bit of time into it, I feel as though I want to get it working a little bit more, because I feel as though the radio's working with me, it's trying, it wants to live. And it is transmitting now. I had it on the analyzer earlier, and I think it was detecting a loud signal, a very loud signal was coming in at 1 microvolt, and it was transmitting, I think it was transmitting about 3.2 watts. So I'm hoping with a little bit of pot tweaking here and there that it's going to work. I've done some other bits and bobs since I last saw you. Let's turn it over. Because I was trying to redo some of the joints on this board, I sprayed some IPA cleaner on it, and then I kind of wiped it off with a clean cloth, and the rag was absolutely stained like quite a bright yellow. I think I've thrown the rag away, so I can't show you. It was absolutely really dirty, and I think it's still a little bit grubby, this circuit board. So I suspect this radio has probably been owned by a smoker in the past, because everything was, I think it must have been thick with just nicotine that had managed to get into it. I mean, it's a sealed unit, but I think tobacco smoke does have a habit of getting into everything. So the board was absolutely disgusting, and it's still a bit grubby in places. Now it still feels a bit sticky around here, so I didn't clean all of it, but you can maybe see that the board looks a bit cleaner around here. And that's because I've been patching up some bad tracks. Now over here, hopefully you can see. Can you see there's like some pieces of wire that I've soldered in? Well, these are a little bit of bodgy repairs, in that I didn't want to spend all day trying to let in new tracks. These are ground planes. Now the radio was actually still working, but I don't think that one's a ground plane, but that certainly is. But there was actually quite a big crack that was running all across this board, and it was mainly splitting some of the ground planes in half. But these ground planes had been fed from multiple sides, so even though we had a crack in one area, the signal was just routing around the other side of the ground plane. Just look at these lovely curvy tracks, aren't they beautiful? I do miss them. Everything's all squares and right angles and 45 degrees. That's absolutely lovely, isn't it? It almost looks organic. I think I quite like a tie or a shirt like that. Almost reminds me of something a bit paisley. Oh, I've just spotted another joint that looks a bit rubbish there. That looks as though it's just sat on it. Oh, and I can even see another joint there where, it looks like you're looking down the top of a volcano, where you look into it and you can see a little ring, like a little caldera forming. So there's obviously a dry joint there that's going to go bad at some point. So this board was absolutely full of dry joints, and it seems to be a bit of a common thing that I seem to be encountering with CB radios. That AM radio I was playing with the other week, I think I said almost every joint I looked at ended up being a dry joint. So yeah, a bit of a common theme going on here. So what I did was, anyway, I just linked up some of these. I cut some pieces of link wire, and I've put a link in there to solve a cracked board. I've put another link there to a cracked board, and there was a very small crack in one of the lines there, and I haven't put a wire link in. I've kind of just resoldered it, and again, it's all ground plane. That I've also resoldered the back of the circuit board. The circuit board is actually just soldered to the back of the casing on here, and all those solder joints had fractured, so I've resoldered them. And I think when I actually did this work, once I'd done it and put it back on the analyzer, it had gone from about 2.1 watt to about 3.2 watts, so we got more or less a watt of increase just by, you know, fixing some of these poor joints and stuff like that. So that was a bit of a win as well. So this CB radio also came with a Midlands microphone, and of course I had to strip this down and put it in a bucket of bleach for a week just to wash out all the bad language from it. So yeah, I've now cleaned out all the swear words and it's ready for some new ones. Cleaned the wire on it. That's actually not a bad wire, and it's nice that, I'm assuming that's an original Midland microphone that came with it. It's not got a new plug. I've resurrected the old plug that was a bit manked up and damaged, and all the wires were ripped out on it. So we've resoldered it, and I've just got some adhesive heat shrink on it there. So what I'm planning on doing now is just getting the heat gun, and I'm going to shrink this adhesive heat shrink down onto the cable, and also it's just going to grab the back of the connector here. And I always do that with microphone cables. I always think it makes a much better and stronger joint. It just puts some strain relief and helps stop the you know, the wires being pulled off the solder buckets, the pins on the connector. So I've got my heat gun and we'll just shrink that down now. Well, unfortunately I didn't make a perfect job of that, did I? Because the heat shrinking has just pulled away from the back of the connector. I wanted it really around the barrel part. If I could have got it. But I think it is going to offer a little bit of additional mechanical protection. So I'm just going to go ahead and reassemble this plug now. Seems to work though. Well, I got another package delivered from RS today, and don't get excited because it's nothing very interesting, but I've not seen an RS box like this. I've got to admit, it looks quite nice. So, don't know how you open it. It's got these pointy up arrows. All them almost goes with a little explosion. That one doing them, it kind of just pops. Should it have come apart now? I don't know. All got a bit pear-shaped. Well, one thing I bought was some new banana plugs, because I found that I've been robbing Peter to pay Paul. I've had a few wire leads and stuff like that, and you know, I've come to wanting to plug them into my test equipment and found that I didn't have the connector I wanted, so I've got another test lead out, robbed a connector off it, and then when I wanted to use that test lead I found that that's got a connector robbed off it. So I've kind of got 3 banana plugs that are like doing the rounds on the end of all my leads, so I thought I'd better buy some more. Not used this type before, so I'm not exactly sure what current these were. Off the top of my head I think maybe they were 6 amps, and they've got a screw terminal because I don't like soldering stuff on unless I have to. So these are a screw terminal type connector, and you can see they've got a hole in them there. Hopefully you can see that, see the hole. And that's because these connectors will stack together, not in a particularly safe manner, I've got to admit, but the idea is you can assemble them like that if you want to join one connector to the other, which is kind of okay for DC, it's not so good for main stuff, but I don't tend to join banana plugs together in that way, so it's not a big problem. So I've got some red ones, and I think I bought some black ones as well. I seem to think they were a couple of pounds each, these, which I don't know. I always think banana plugs are expensive, but, well, yeah, way of the world, isn't it? So there's some banana plugs. So when I made those RF matching pads, I was scratching around to try to find some 50 ohm BNC connectors. So all I've done here, I've just replenished my stock, and I've then got a part number on. Part number is 512-1174. So these are 50 ohm BNC connectors, designed to be chassis mounted. They've got solder buckets on the back of them, and they come through with a tab washer, and also one of the star washers that I was talking about recently. And I think these were about the cheapest that they actually did. They're I think they're nickel plated rather than being silver plated. Silver and gold is always nice, isn't it? But yeah, I just bought the cheap nickel ones because I don't really need the enhanced cost or the enhanced reliability of you know, silver plated. They're good enough for what I've used. Now the other thing I got was some BNC mountable sockets. Let me get one of them out because I've not used one of these before. So hopefully you can see that these are designed to be PCB mountable. Not exactly sure what the leg spacing is. They don't look as though they'll go through you know, the holes on a Vera board. They look a little bit too big. So here's a bit of cheap and nasty knockoff Vera board that I think I got imported from China. And the main feature of this is it was ridiculously cheap. I think I got like 5 or 6 sheets of it for a couple of pounds, and that included the delivery. So one disappointing feature I've found is that these BNC connectors, I'm guessing they must be on some type of metric pitch, because unfortunately they don't fit the holes in this, so that's a little bit of a fail. So here's our York JCB861. Well, I got this idea from watching Mike's radio repair, because he makes a little adapter. So when he wants to plug test gear, he wants to get access to the microphone input, what he actually does is he takes an old microphone plug and he kind of sticks it in the radio, and then the back of the microphone plug he has a piece of Vera board. It looks like it's Vera board soldered onto it, and on that piece of Vera board he has a clicky switch. So let me just find a clicky switch. Something like that. And he also has a BNC connector, which is what I bought these for, and they're also installed on the board. And what that allows him to do is he can use the BNC connector to feed a signal into the microphone and you know, transmit that for when he's trying to do synad measurements and stuff like that. But rather than having to hold the key down on the microphone, I think you saw one of the boxes I made previously that had a switch on it. He uses a little switch on the PCB there, and what he can do is he can just very easily put any radio that he's working on, he can put it into transmit or receive, because you know that it's much easier when you're taking measurements to flick the switch rather than having to keep holding the microphone key. So I thought that was a good idea of Mike's. Unfortunately, I thought I had some old radio connectors, and that's what I was going to use. I was going to just break apart some old radio connectors I had to actually to make some of these adapters, but as it turns out I can't find them, so I'm going to have to do that at some point in the future. I was hoping to do that today, but unfortunately not worked out. Okay, I do remember purchasing this. So this is a radio kit, and this is one of the more popular ones that you can buy on eBay at the moment. And I think it's ridiculously cheap. It's something like £3 or £4 delivered. It's not very much. And you've got everything here to build an AM radio. So my plan was that I thought we could build some of these radios over the Christmas period, because you know how much I enjoy building kits. And I don't know how good a radio it is, but well, we've got a little printed circuit board here, which is it's not gold plated, it's just copper. What sort of material is it? It's not FR4, it's phenolic resin. We've got a case here, a little plastic case. Comes with a speaker. You never know, that speaker might end up in the signal tracer. It looks better than the one I'm using at the moment. And 0.5 watt 8 ohms, that's perfect. So we've got a spare speaker there if we need it. And we've got a bag of components. Yep, I can see some matching transformers there, Toco coils. Looks like there might be some push buttons. There's some knobs for the radio there. Variable capacitor there. Looks like there's one of those flat form potentiometers there that you find in little transistor radios. So basically a complete kit of parts to build this AM radio. It must be AM, it's got that ferrite antenna. Don't really want to spend too much time going through this, because I plan on building this up over Christmas as a little project. So it comes with quite a nice laid out circuit diagram. In fact, it couldn't be better. I've got a list of components there. We've got a layout here of the board with an overlay of the printed circuit board. Got a nice schematic on that side. It's all very clearly labelled. All the components are identified. Oh, we've got an IF of 465 kilohertz there, and it says that it goes between 525 kilohertz and 1.6 megahertz. So yeah, so we're going to enjoy building that, aren't we? Look forward to that. I think I said in the early episode, I highly recommend anybody who's into electronics, build some kits, it's great fun. I mean, even if you're capable of designing the stuff yourself, just the pleasure of not having to order all the parts from Farnell and RS. Place your order on eBay for £3 and then you get to enjoy an evening constructing and playing with a radio. What can be better, cleaner fun than that? Well, I can think of one or two things which would be better in honesty, but yeah, wife would say no, so looks like I'll be building radios over Christmas. What's new there?